Hello, welcome to a session on surface areas and volumes. We have already been taken cube, cuboid, cylinder, cone, and here we are to take up the sphere. Let's first note down the formula for sphere. Surface area, I'll write down that we are taking up sphere, so I'll just simply write surface area of sphere. That's given by 4 pi r square, and obviously it will be given as square units in any units. Curved surface area of a hemisphere, this I write here, hemisphere, will be given by 2 pi r square, and that too will be in square units. When we are talking about the total surface area of the hemisphere, it will be 3 pi r square. I tell you why. Total surface area of hemisphere will be 3 pi r square, the same square units. Now hemispheres would simply look like this. So the area will be this part as well as this part. So it is pi r square for this and 2 pi r square for this. It becomes 3 pi r square. Let's take a few application questions now to understand this better. A sphere, a cylinder, and a cone are of the same radius, and there is a gap here, same radius and same height. We have to find the ratio of their curved surfaces. Okay, now if this is a sphere, radius we are representing by, suppose, r. So I'll write that radius, if I'm taking the radius of the sphere to be r, so obviously radius of all of them, the cylinder as well as the cone, will be r. Then height of the sphere, which is the height of the sphere? Suppose this becomes the height of the sphere, so it is 2r. This is 1r, this is another r, so height becomes 2r, and that will also be applied to cone as well as the cylinder. Now we have to find the ratio of the curved surface of sphere. What is the ratio of the curved surface of sphere? It is 4 pi r square. I'll substitute it later if any. And then cylinder, curved surface area is 2 pi r h, and for cone it is pi r l. So here we have to calculate L later on. So now 4 pi, r has been substituted with r, so let it be as it is. That is 2 into pi into r, and the h will be substituted with a 2r, and that's making it 4 pi r square as well. And the last one here, we calculate L here. I'll do it separately because L is given by h square plus r square. H square is 2r square, that is 4r square, and r square will remain as it is. That makes it 5r square. To find the root over, it will be root 5r. So I'll substitute here pi r and root 5r. So here is pi r square, here also is pi r square, and here it becomes root 5 pi r square, thereby cancelling all these three and we are left with only 4:4:5. Let us now move on to another screen and take up few more questions. Let me write down the question again here. Says the internal and external, let it be as ext, diameters of a hollow hemispherical vessel is 24 centimeter and 25 centimeter respectively. The cost to paint 1 square centimeter is rupees 0.05. We have to, oh, I missed it somewhere. I think you cannot see that one. Here I write is rupees 0.05. We have to find the total cost to paint the vessel all over. That means we have to paint the inner portion of the vessel as well as the outer portion. So what will be the formula first to be applied here? Outer area will be given by a pi r square. I'm taking a capital R there. So like this it would look like. And then hemispherical, if I draw this like this. To paint it, we will have to take area of the outer surface, area of this inner surface. I'll denote it by a small r. And also this portion. How do we calculate this portion? Maybe I can shade it. Yes, this pink portion has to be also painted. Now how is that? Only for the top part. Inner part we don't need, but the top part we have to paint this. So that is external area minus the internal area, and that will be, so I write area of the top. Area of the top is pi r square minus pi r square. So we have to add all these three things to get the area to be, did you say I made a mistake? Yeah. To find the total area to be painted, because only when we find the total area to be painted we multiply it by the per square feet cost to get the total cost. To add this, I'll substitute with these figures later on once I derive at the final formula, because herein I can take common area. What is the curved surface area of a hemisphere? I think it's 2 pi r squares. 2 pi r squares, yeah. Plus this. Now this is giving me 3 pi r square, and this minus this will give me a plus pi r square. So pi, if taken common, will the formula be left with me is 3 capital R square minus a small r square. Let us substitute this in the formula. So 22 by 7 3 r square, capital R will be, this is the diameter, capital R will be 12.5 centimeters, and on the other hand this will be 12 centimeters. So it is 12.5 square minus 12 square. So it is 22 by 7 to 3. So we have to multiply 12.5 into 12.5, that's 156.25, and minus 144. 156.25 multiplied by 3 is 468.75, and 144 subtracted from it is giving 324.75. 324.75 has to be now multiplied with a pi. Is it so? Oh, why did I make it once I take common, how will I left with here a plus? So I have taken a pi common there. No, it is right. It is 3. Yes, the formula here was plus and I made it a minus there. Sorry for this mistake. Because then this will change, because 3 into 156.25 plus 144 is giving 612.75. That has to be multiplied with a pi, and it will then give me 1925.79. if I round it off, I'm getting it some decimal up to 3 decimal places. This is the total area to be painted. Now each square meter of area costs 0.05 rupees. So the total cost of painting will be 96.29 rupees. Again, it is rounded off. Let's move on to take another one. This I think I can leave for you to get to solve. I can just help out, informing you about how to be done. There is a wooden toy, it says, which is in the form of a cone surmounted on a hemisphere. The diameter of the base of the cone is 6 centimeter and its height is 4 centimeter. Find the cost of painting the toy at the rate of ₹5 per 100 square meter per 1000 square centimeters. Let us draw how it looks like first. It becomes difficult for me to draw if so I'll be drawing the hemisphere first, and then we'll be trying to draw the cone on that. Yeah. This is how the toy actually looks like. The wooden toy is in the form of a cone. Oh, this is surmounted. Sorry, it is surmounted on a hemisphere. Now it looks like it. The diameter of the base of the cone, this diameter, it means, is given as 6 centimeters and its height is 4 centimeters. So this height is given to be 4 centimeters. we have to find the cost of painting. So to find the cost of painting, you'll have to take the lateral surface area, this is the curved surface area of the cone, as well as the hemisphere. The hemisphere's curved surface area is given by 2 pi r square, plus the curved surface area of the cone is given by pi r l. So what you can do is you calculate L separately, because if the radius is given as 6, the diameter is given as 6, the radius will be 3 here. So you apply a Pythagoras theorem to first find L, that's given by h square plus 3 square root over. Once you find, you can substitute this in the formula, taking pi common first, and the r as well you can take common because both of them have got the same r. I can help you by giving the answer so that you can check. So cost of painting the toy will finally be only 51 paisa. Try to do this by yourself and check the answer if you get it right. Thank you.